Hello, this is Ms. DB. In this video, we are going to solve quadratic equations by graphing. So you see I've already opened up Desmos. It's just www.desmos.com/calculator. And you can use this to help you graph and find the solutions for these problems. So first of all, a zero of a function is a value of the input x that makes the output f of x equals 0. In other words, the zeros are the x-intercepts. These are also called the roots, and they are also called the solutions to a quadratic equation. So if it's the function, we look at the zeros, which are the x-intercepts, and when we have an equation like we replace y with 0, then we'll be calling this either the solutions or the roots. So we are going to solve these by graphing. So here's an example problem. They show plotting out some example points and then putting them on the graph. You can do that if you want, but you can also use technology to do this. Might be a little bit faster. And we've already spent a whole folder on the vertex and axis of symmetry and finding all those important points. So now we're going to be using technology. We're going to graph these, and for these first problems, you do have to attach a screenshot or a link to your graph for 1 through 5. For the next problems, it says you do not need to attach the graph, but for these first 5, you do. So we'll look at how to do that. Let's look at, it doesn't matter, we'll do number 2. So I just type in exactly what shows in Desmos, 2x squared. To do the squared, you use the up button, shift 6, plus x plus 4. You can also, I was just typing on my keyboard on my computer, but you can also use the Desmos keyboard, and then you can use this to be the squared button. And you'll see this graph. You can click on it to move it around. You could zoom in if you needed to get a better look. Now we are supposed to be finding, this is number 2, the solutions, which are the x-intercepts. So if I just look at this, I'm not sure exactly what they are. I can zoom in more. Oh, there, I can see that it's, this one here is between, where's 1? Is between 1 and 2. So you can zoom in to get a little bit better look, but then you kind of lose what the graph looks like. Another way to find the best estimate, like I know this is more than 1.5, the other way is to click on that point where the graph intersects the x-axis, and Desmos will tell you its value is 1.686. That's one of the solutions for number 2. And I can click on this one and find the other value of the other solution. There will be 2 solutions for this one because this graph goes through the x-axis at 2 points. So I'm going to take a screenshot of this now that I have a nice graph. So I'm using a tool in Windows computers called Snip and Sketch. So I'm going to go ahead and include what I graphed just to make sure that when I paste it in there, I put that in the right spot. And then I can copy this, and then I can put it right here on my worksheet for the graph. It's okay that it's big. We're not wasting paper because you're just going to be attaching a file. So I also need to type the solutions. One of my solutions was at -1.186, and the other one was at 1.686. Now, can you round these? Yes. You could round that to -1.2, and that if you don't want to worry about whether you're rounding correctly or not, you can go ahead and type all of the digits that Desmos gives you. These are also been rounded. Sometimes you'll get exact answers for the roots, like integer answers, and sometimes you'll have a decimal approximation. So that's how you would do number 2. I'm going to do one more just to show you how you can graph, and we could either X out of it like I just did, or I could have just hit it. I'm going to show you the other way, remind you how to do these if you want to do a link instead of the screenshot. And this time I'll use the squared button right here. Now this one doesn't say y equals, it says equals 0. You don't need to type the equals 0 part in there. Then it just gives you two straight lines. So don't do that. Type equals y if you want, or just type the part before you get to the equal sign. All right, so now I'm going to look at my graph. There it is. And let me get the solutions, because I need that. So one of them's at 0, I think. Yep, that one's a nice one. And the other one is at 3.33 or 3 1/3. So which one was this? This was number 10. So I've got one at 0 and one at 3 1/3. Or you could say 3.333. All right, now if you don't want to do a screenshot and mess around with that, let me put the points back on there. I can get a link. So you click on this Share Graph button here, and this is a link right to this exact graph. And you copy it, and then you can come over here to number 5, and you can go Control V, and you paste it, and then hit the space bar one time so it becomes a live link. You can also go to, under Editing, there's a paste button, isn't there? Paste. I have this smaller than it usually is, but you can find, there's a drop-down menu somewhere where you can paste your link as well. All right, so in 6, 7, 8, all of these, you're going to do the exact same thing, except that you do not have to attach your graphs for these. You just have to find the solutions and type them in here. And if you get them right, I'll know that you made the graphs correct. Remember that in these ones, really, we're not going to graph the equals 0. We're going to graph equals y. Otherwise, you'll just get two vertical lines through the solutions, and it won't look like a parabola. Okay. Next section, we're going to do a little bit more. It says to find the roots and the vertex of each quadratic function. You do not need to attach the graphs round to the nearest 10th or 100th. Number 12 has been completed. So in number 12, I attached the graph because otherwise you wouldn't be able to see what I got. So I graphed x squared plus 3x plus 6, and I got this graph right here. Now the roots is where it crosses the x-axis, but it does not cross the x-axis. There are no roots in this problem. Now, most of your problems you will get roots, either one root or two roots, but sometimes you get no roots in a quadratic function. That's something that can happen. So in this one, it never crosses the x-axis, so I would say none for the roots. I also have to name the vertex, and I did by clicking on that point and then typing in what I got. So Desmos really found the vertex for me. We could find the vertex with the equation that we used last week. X is equal to no, we can't. We can find the axis of symmetry. Sorry, we can find the axis of symmetry's x value using the equation that we found last week, which is b divided by 2a, and I need a negative in front of that. So then I could use b is equal to 3 and a is equal to 1. But this only gives me the x value of the vertex, and I would still have to find the y value. So it probably is easier to use the graph to find this. If I wanted to do it without the graph, I would plug now this value of x into this equation and solve it to find y, and I would get 3.75. But you can get the vertex from the graph, so you might as well just do that. So then there's a few problems where you're going to do that. All right, let's look at number 16. Number 16 says to graph these two equations on the same screen. Find their roots and vertices. All right, let's do that one. Let's do number 16 together. Y equals 2x squared minus 4x plus 8. Okay, so there is that one. Now look at that one, has no roots, does it? It does have a vertex, of course, it's right there, but it never crosses the x-axis, so this one does not have any roots. Now I'm going to graph y equals x squared minus 2x plus 4. Okay, that one is right here. Let's look at this vertex and this vertex, because it says to look at their vertex and their roots. So neither of them have any roots. So you could write that for what is the same. How are they different? Well, let's zoom out a little bit. It's clearly the green graph is higher. So that is, which one was the green one? That was the first one. The first function is higher. The vertex is at, let's see, what was that, 1, 6? 1, 6. And the second has a vertex lower than that, and that one had a vertex at 1, 3. Here's another way that they're the same. One thing that they're the same is that there's no roots for them. Another thing that is the same is that they both have the same x value of the vertex. And that means that they both have the same axis of symmetry, because the x-axis of the vertex does tell you what the axis of symmetry would be. The axis of symmetry would be at x equals 1. It would be that line that goes there, right through both of them. And they're different because one of them has been translated higher. Also, 2x squared minus 4x plus 8 is more narrow. It's skinnier. So we could add that for a difference as well. First function is skinnier because multiplying by 2 actually makes it be skinnier. And then it says, how are they related to each other? It seems really hard to see how they're related to each other. Let's see if we can factor these like the hint says. So I'm going to factor this, and then I'm going to factor the second part. Now, factoring is something that's going to be very important in this folder, and we did lots of factoring earlier in this quarter already, so you should remember how to factor. You can look back at weeks 11, 12, 13 to review how to factor. This is a trinomial. And I factored out the common factor of 2. On factor, it was exactly the same as the second equation. X squared minus 2x plus 4. So they're related to each other in that the first is equal to 2 times the second equation or function. If I were just to take this function and multiply it by 2, I would get the first one. So that I was trying to do more work than I had to do. All right, so number 17 is very similar. You are going to graph them, and you're going to see how they're related to each other. And then there's one more question. This is a real-world-based problem. You can graph the equation, and then you can see how long does it take the ball to come back to the ground. Let's just graph this function quick so we can look at what's happening. It says y is equal to negative 16. Instead of t, write x squared plus 60x. And the question says, how long does it take the ball to come back to the ground? So this point right here at 0, 0 represents them throwing the ball up. They throw it up, 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 up. Now it's pretty hard to see what's going on here, so I'm going to go all the way up to, I don't need to go so far on this one. I only need to go to like 8, but on this one I have to go past 60. There, now I can see better what's happening. So the ball went up all the way up to here, and then it started to come back down. Right here, this x-axis is the time. So this is after 1 second, 2 seconds, 3 seconds, 4 seconds. Here would be 5 seconds. It didn't even last 5 seconds in the air. It only lasted this many seconds. And the vertex shows how high the ball went. It's very peak, it was already up to 56.25 feet. So that would be the answer for the maximum height of the ball. And the seconds would be this one here. All right. Thank you very much. Have a wonderful day.